In this sixth video, what we're going to do is we're going to have a look at something called a differential equation. Sounds complicated, but at the level we're dealing with it, at higher, what it means is they're going to give you the derivative and a value of a point it passes through, or give you an x value and a y value separately, in order to let you work out what the original equation was. So we know that the inverse of differentiating is integrating. So we start off by having to integrate. So a typical question like this one, it says, the gradient of a tangent to a curve is dy by dx equals 8x cubed minus 2x, and the curve passes through the point 1, 6. Find the equation of the curve. So what we have to do is we have to integrate to get back to the original expression, the expression for y. So if I look at the first one, the first thing I'm going to do is y equals, and it's the integral of the derivative, which is 8x cubed minus 2x dx, which is not a difficult integral to do. What we've got is 8x to the power 4, raising the power by 1, divide by the new power. That, remember, x is x to the power 1, so it becomes 2x to the power 2, over 2, plus some constant of integration, c. So that was y, remember? So that gives us y equals 2x to the power 4 minus x squared plus c. But then what we do is we have a look at this point here. We look at it, we can see that when x is equal to 1, y is equal to 6. So this will let me, if I substitute in these values, work out what c is. So 6 equals 2 times 1 to the power 4 minus 1 to the power 2 plus c. Well, 1 to any power is just 1, so that's 2 take away 1, which is 1. So that becomes 6 equals 1 plus c. So c has to be 5. Now we know what the constant is, we can put it back in here. So the equation that we did start with was 2x to the power 4 minus x squared plus 5. And that would be the answer to that one. This second question here, it says, find the solution to this differential equation, ds by dt equals 6t squared minus 3t plus 3, given that s equals 6 when t equals 2. Quite often, you might see s and t used in differential equations because t could represent time and s could represent displacement. So ds by dt in this one would really be the velocity. So if you had an equation for the velocity, but you also knew where it was at a certain time, you should be able to work out an equation for its displacement. So that sort of sets it in context. So it's not always in terms of x and y. Sometimes you'll get it in terms of s and t. But we do it exactly the same way. We've got to integrate and then work out what the constant is. So that's what we're going to do. S will be the integral of 6t squared minus 3t plus 3 dt. So if we integrate that, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, any number term becomes a t term, and we have this constant to work out. Tidying it up a little bit, we've got s equals 2t cubed minus 3 over 2 t squared plus 3t plus c. Now, to work out the c, we've been told when t is 2, s is 6. So we'll substitute these two values into there. And if we do that, if we replace the s with the 6, we've got 2 times 2 cubed minus 3 over 2 times 2 squared plus 3 times 2 plus c. Right, so let's have a wee look. That gives us 6. 2 cubed is 8, so that would be 16. 2 squared is 4. Divided by 2 is 2, times 3 would be minus 6. 3 times 2 plus 6 plus c. So what we had is 6 equals 16 plus c. So c would be equal to minus 10. So now we found out what this constant is, we can write down our formula. It's s equals 2 t cubed minus 3 over 2 t squared plus 3t minus 10. And as I said, that might represent a displacement at a given time. Okay, you should now be able to attempt the 6th exercise. And remember, after that, you can have a go at the quiz.